Larson. We're presenting on a tool that we've been developing that piggybacks off of Yelp's OSXCollector. It's for forensic analysis on the Mac platform. Of course, this is...
I'm Justin.
This,
Can you guys hear me?
no.
Probably got to turn it on. There we go. Can you hear me now? Awesome. User error. So I'm Justin Larson, obviously, that's my name. I work at Workfront, it's web app security engineer. I get to build a lot of tools for us. It's pretty fun. I'm the handsome one of the group, so.
And I'm Chris Henderson. I also work at Workfront, and I'm the grumpy old man, so according to Justin anyway. So there's, I don't know, how many of you have the Mac platform, Mac systems in your work environments? And how many of those of you that raise your hand, the majority of your systems are Mac OS? Okay. That's kind of a trend that I think, especially in small startups, that's kind of a trend, right? Is the Mac platform dominating the environment. We're no different. We're a heavy Mac shop, and we've noticed a big trend. I don't know if you've noticed the same thing, but we're starting to see a lot more malware, adware, and et cetera, popping up in our environment. Bit9 just released a report. It's an interesting report that gave some pretty good statistics. I haven't, full disclosure, I mean, it is by Bit9, right? So they obviously are utilizing that information to help push their product, which it's a good product. I'm not knocking the product at all, but I haven't looked at the statistics. So they sound scary, but I haven't analyzed the statistics. And as all of us know, statistics can be pushed one way or another to support your needs, right? So, but they do have some interesting information. In 2015, there's been more malware found than the previous 5 years combined. And in 2015 also, there's been 948 unique samples of malware found compared to 180 between 2010 and 2014. That's pretty crazy numbers. The majority right now are classified as adware, but I don't know if you've been around. Like he said, I'm the old grumpy fart, according to him.
Say fart.
But I've been around long enough that it does feel like the early days of Windows malware. Here's another graph to show you that information. Again, the thing that we've found is, yeah, Bit9's data is supporting what we're seeing. We are seeing an increased amount of firewall event alerts on our end user systems. We've noticed a huge increase over previous years. We're to the point where we're at least, it fluctuates, but it probably averages out to be about every other week or every week that we have an end user system that is having some kind of odd behavior that the firewall is blocking on. And I don't know if you've attended we use Palo Alto's, and we use the DNS sinkholing feature, and that's part of where we get this data from. The problem that we've found, and if the Palo Alto guys were in here, they would call us out on it, but we don't have, right now we don't have the DNS sinkholing feature set up properly. And so what it's led to is, yes, it's been awesome. It blocks these malicious calls out, but the problem is we have little visibility. We know what machine it was, we know the user associated with it, but we don't know what they're going to. We don't know what happened on the system. We just know something went wrong. And so in the past, what we've had to do is all we know is something's wrong, and as the system continues to alert, the only thing we can do is wipe the system with a fresh install, get the data back over, and it solves the problem. But we have no idea at that point what happened, how the malware or adware, et cetera, got on the system. And part of that was because there were a few options for Mac OS forensics. There's not a lot out there. It's something that's kind of it's a new area where I'm sure it will mature, but it's early stages. The other issue is I'm sure we're like several of you. We're limited in the amount of security resources that we have dedicated to looking into these events and figuring out what happened. So the problem for us is there was little to no or even very slow analysis on our part to be able to figure out what was triggering these events, incidents on these end user systems. So how many of you have heard of Yelp's OSXCollector? Anybody? Okay.
Is anybody using it?
It's it's, if you've heard about it, if you have Macs in your environment, it is it's worth a look. It's a great tool to help you do analytics on Mac OS systems. It's an open source project, and the really cool thing about OSXCollector is it's a single Python script. So there's no modules that you have to install, and it's just one single script that grabs all this data, and it's awesome because it collects all the information that you need to be able to determine how is there malware on the system, right? And how did the malware get there, and that can help you lead to find ways to stop that malware from infecting further systems. Again, single script with no dependencies. The other great thing about it is the output is a single JSON file. It also collects other system log information and dumps it in one place so that you can have all the system logs and other log files. There's one for it'll gather your VMware logs and several other files. So it all puts that into that collection.
And it's grabbing from, there's a lot of SQLite databases on the Mac that's storing all this information and keeping track of all these things. And so all it's doing is it's going in and querying all those and pulling out all the data from like Chrome or Firefox and all your downloads and stuff like that. So.
Yeah, and it's pretty crazy the amount of data that it does grab. The fact that it's a single JSON file makes it very easy to parse through the data, and the other nice thing is it does, depending on how long the system's been up and running, will dictate how big that collection is, right? So one of the cool things is you can also specify different sections to run. So if you only want to know information, well, here's all these aren't all the sections, but here's a good, this is part of the sections, and you can run the script to only collect the data on these sections. So you got your the startup items, application downloads, all that browser history, all that kind of information is grabbed in this collection, or you can just do it on those specific items. So there's different ways that you can look at the data that's collected. It's a really, wow, that's even worse. Sorry for the screenshot, but you can do standard command line, use standard command line tools to parse through the data. So grep, this is just a simple cat of the file, grepping for a specific time, a range of time, and this will output everything that was collected by the OSX collector on that system during that range time. So this is browser history, downloads. This is everything that you can start looking and start doing forensic analysis on the system. This is another example of basic analysis. This is another cat, but this is also using jQuery. So jQuery gives you a lot more ability to get further into the data easier than a lot of sedoc commands. So in this one, again, it's searching for the date range, and then with this jQuery, piping it through jQuery, and then being able to look for anything with a that's tagged URL during that time frame. So I don't know if you can see it, but right here, this is one of the systems that we ran analysis on, and during this time frame, this guy was hungry. Obviously, he was ordering from Jimmy John's, from Lunch Bob. So anyway, great information that you can collect on the system. So then you move on to advanced filters. So advanced filters are give this more power, OSXCollector. So it does. It has the find domain filter, which is exactly what you would expect it to be. This grabs all of the domains that this system has visited for its as long as the history has been collected. The find blacklisted filter. This you can configure this to tie into other online blacklists, so you can configure it to go out and look. This makes that domain filter even more powerful, because then it can look at your blacklist and see if there's any flags there, right? It'll flag that information. Related file filter. It grabs all the files that are on the system and hashes them, or provides a hash for them. The Chrome history filter and Firefox filters are exactly what they say. They are. The cool thing about it is they do have a core. They call it a core and a page filter, I think is what it is. But they're keys that they flag on, so that you can actually see whether the user clicked on something, was redirected to something for your analysis. So you can determine whether, you know, if you're that way, you can point finger at how it happened, the infection happened. So where it's really powerful is it's the most powerful feature of OSXCollector is the API filters, and what these do is these connect to OpenDNS. Unfortunately, with both of these, with OpenDNS, you have to have an umbrella license, umbrella something. I'm missing a word there, but you have to have that license to be able to have an API key to make that call into OpenDNS. So that's one of the downsides to for a small shop. That's not cheap, right? To get that licensing. Also with VirusTotal, VirusTotal offers their free version, but you're very limited on the number of queries that you can submit, and so analysis, if you could take a long time, and there's tons of hashes that are collected that during that gathering. So doing analysis using VirusTotal alone with the free version is very restrictive. If you want more information on the ins and outs of OSXCollector, you can see Yelp's GitHub page, and also the most recent talk was given at BrewCon. It's online on YouTube on the BrewCon YouTube channel, and one of the guys from Yelp goes into a deep dive into OSXCollector. So when we found OSXCollector, it was great. It gave us a tool that we could utilize to try to figure out what's going on in our environment and how it's happening. So we were able to go from collecting little to no data from systems to being able to collect data. We wanted to figure out, now that we had that, how could we speed this up? How could we go from collecting that data to analysis in a much shorter time frame? Could we simplify it? Because we're such a small team, could we simplify some of this so that Corp IT assets could run initial analysis and then escalate to us instead of us having to do everything and kind of disperse that work since we're such a small team? How we went about collecting the information was also slow. So typically we would have to send that script via email or a thumb drive, which made it very slow, and for a lot of users that wasn't easy for them to deal with, having to manage a Python script is very easy for us, but for end user,
the sales guy's not going to be able to get on the command line and run that. So
yeah, not fun. I mean, I think all of us have probably had some tech support background, and walking some people through running a script, you're pulling your hair out. It's crazy. There we go. All right, I won't touch the computer again that way. Anyway, yeah, I see that. Yeah. So what we did is we created an application that people our end users can run. So if we see an event that's been triggered on the firewall, we can call them up quickly, and they run just an application that's installed on their system. And what it does is it just runs the OSXCollector, and then for us, what we've done is we have it automatically upload that data to our ticketing system, and then that ticket's assigned out to us so that we can download that zip file and start analysis on the system. And that's saved us a lot of headache by making that application. So back to the other issue is if we want to offload a lot of this to our Corp IT guys, a lot of them can be intimidated by the command line, and so having them do analysis, even just simple greps and running some jQueries, isn't really a realistic option for us. A lot of these guys are new, in the tech world, and so for a lot of these guys, a UI is preferred. UI also is a lot easier for us to do training with them, and most importantly, restating the obvious, right? It allows for non-security staff to help us in analyzing data, and to allow this. We want to make sure that we don't want this happening to our staff here.
awesome.
All right. So that leads us to what we decided to do is to build upon the OSXCollector and create a web interface for it.
Yeah. So with the OSXCollector, when we first got it, I noticed that it dumped everything in JSON, and so to me that is really easy to import into a database, a Mongo database. And so I thought, well, let's just visualize this data. I'm a visual learner, so I like to see things. So we chose a framework. We went with Meteor. Anybody familiar with Meteor? Nobody? Cool. It's kind of I'm really into it right now, so that's why we went with it. But it's reactive, so you don't have to refresh your browser when things change in the database. It's always listening. And so,
which we liked because we figured this tool would be something that multiple people can be looking at the same event, and having that data automatically refreshed was important.
yeah, so you don't duplicate effort. So, but our tool is more than just the UI. We're also doing some automated analysis, and so we get OSXCollector, and it gets us down to like hours that we have to spend going through and looking at everything and analyzing it. And so I wanted to write something. Obviously, I'm lazy, so I want to script everything out. So I wrote the first thing when you import, you can run analysis, or you can just import the JSON file into Strata. And when you import with analysis, it'll go through, it'll find every hash, it'll check it, it'll check those hashes, it'll check all domains, all URLs for you. And then when you go into the UI, you don't have to dig through those and find them already. It'll already flag the ones that meet certain criteria that I'm going to build into the tool to meet your criteria of what you want to be flagged on. For the UI, you can also, there's some command line stuff if you want to import command line and do some other stuff. But there's a domain and IP blacklist that I've created that it takes from other lists out there on the internet that you can just download for free, and then it just imports that. So when it's checking domains, it's not going to make an external call at first. It's going to check your own blacklist first, and then it will go out and check some of our other APIs to see if the domain is a blacklist, if it's not a good domain for your users to be on. And then also there's a hashing database, so we don't have to send everything to VirusTotal every single time. So if you've got users that are have the same virus or whatever, or malware on their machines, it's going to check your hash database first before it makes a call to VirusTotal or Xforce, IBM's Xforce. And I did that just to save on making external calls, because it's definitely faster to just check that database. But you'll build up your own whitelist, blacklist of hashes that you'll know that are vulnerable or that are malware or not. So these are the integrations that we've worked on. So the shadow server is just an open, you can just send a hash, and it's a whitelist, so it'll just tell you if it's in that list, then it's good. It's a known application or whatever, and that it's okay to have on your system. But if it's not on there, it doesn't necessarily mean that application is bad. It's just not on the whitelist. IBM Xforce, I'll pull that up in a second, but you can send a lot of things that you can send URLs, IPs, hashes, a whole lot of stuff, and it's free. And I've sent thousands of requests in a minute, and it hasn't locked me out yet. So I'm going to keep doing that. And then there's a VirusTotal. We're just using the public right now, so that only takes 4 requests a minute. So I have to throttle. I can only send a request like every 15 seconds, or else we'll get locked out on that one. And I want to build into it, if you have a VirusTotal key, then you can, in a license, you just put in your license type, because they're varying different licenses, like 1,000 per minute or whatever, and so that'll make a check so you don't send too many for your license. But the blacklist, these are some of the places that I pulled blacklists from: DShield, Joe Wynn, and Malware Domain List, Malware Bytes, Malware Patrol, and then the blacklist IP is the same thing. And those are just going into the database, so you don't have to make those external calls to other places. And we're working on OpenDNS. Like I said, we didn't have the license. It's like $100,000 for a license for that tool, so we were waiting on budget. So I didn't build into the tool OpenDNS integration yet. Do the Palo Alto autofocus. That's another one that we're looking forward to. They just haven't really released it, so that's why we haven't done it. And then ThreatBut. I don't know if you guys know ThreatBut. That one's just for fun, but I want to work on that one sometime. So, and now we can demo a little bit. I'm going to sit down because I don't like to type standing up. Oh, and if you have any questions, like if you see something in the UI that you want to know what it does or what it's for, just shout out. That's fine. So this is it. Beautiful, right? So actually, we're going to take a look at the command line first. So this is just a little help menu. So you can do a lot of different things from this. You can import, run analysis. You can just import a file. And the reason you would want to just import a file, if you'd really know the specific time or what application it was that was causing problems, and you can run analysis really quick instead of waiting. Sometimes running the analysis takes a long time. Like we had one file that had like 200,000 entries in it, and it took probably 12 hours to run analysis. So it's kind of like a set it and forget it, and then wait till it's finished to come back. But it's better than sitting and doing analysis for 12 hours in the command line using JQ and grep and whatnot. So it's doing it all for you. You can remove all the data at once. You can remove a specific incident, or that's just one file that you put in, and you can make single calls to VirusTotal or IBM X-Force. I'll show you the IBM X-Force real quick. So it's just a threat exchange. Has anybody heard of this before or used it? Okay.
It's a pretty cool tool, and you can get a lot of threat analysis data off of it. It's to my knowledge, it's free, completely free.
Yeah.
They have a lot of alerts on notifying you about different security events or trends and things. So it's a great tool that you would want to check out.
Yeah, and you can just go onto this, and you can run your API, what you would run in a script from here, and just to see what it would give you. But yeah, it's really awesome. Gives a lot of good data. And this is Shadow Server. Pretty simple. You'll send the MD5 right here, and it either spits back some information or it just spits back the hash. When it spits back the hash, it just means it's not there. And then VirusTotal. I think everyone should probably know VirusTotal. It's pretty big. They're a big player. So we'll just log in. Don't judge me for saving my password. So I mean, it's definitely, we're still in development. That's why we were going to release it today, but it's a lot of work to build an application. I'm not going to lie. So we're a little behind, but it does function. So here we have a couple of collections that we have, and you can see that it's already flagged. In this one, 3,000 items. In this one, 23. And we want to import another one. We can import from right here. If it'll pop up.
And some of these collections that we have are actually from our end user systems. We've obfuscated the data, but they are actual end user systems.
So the pop-up's not coming up, so that's weird. I probably broke something. I was playing around with it earlier, so good chance it's broken. It's a demo, so they never work, right? So we'll just send it in the command line. So I'm just going to pass it the A flag, and so it's going to run that analysis. So it first uploads the whole file at once, and then it starts, and it spits out tons of, I guess, garbage. I don't know. I hate running scripts and not knowing where it's at in the script, so I like to give myself something. But it's going through all the collections. So this one's going to go pretty fast. I say fast, it's a minute and a half. That's because it's already hitting, we've already ran it, so all of its data is already in our local database. So it doesn't need to go out and look at X-Force or VirusTotal. And so that'll speed it up, making those requests. Actually, it still goes to virus total here at the end. And like I said, so I had to time it every 15 seconds to send a request, so now we're waiting 15 seconds. That's what makes it the longest. So if we go back to UI, we can see this is the one we're importing right now. It's already there. Wow, it looks really bad on this screen. No. So there's 5,204 entries in this one file, and you can see that it's flagged 2 applications for us. So we can just go in. So this will list all of your applications, and we can go in and filter. We just want the flagged ones. So, and we can go in and see what's going on in there. So this gives us 3 different hashes. It gives us SHA-2, SHA-1, and then MD5's down here. But it tells us the file path. And this is all data that we're getting from OSXCollector. Everything below the hash is stuff that we've run on analysis. So if you want to look at the shadow, what the API for shadow gives us, I'm going to make that clickable eventually, but you just go there and see what it returns. And so I give it everything a score based on if it's found or if it's not. And shadow results, so if it's not in the shadow database, then I give it a score of 1, and if it is, then it's a -1 because it's okay, because it's a whitelist. But then IBM will give it its own score of 2, and that's out of 100. So it's not 0, but they have seen something with it before. And then virus total gives it a score of 1. So that just means 1 out of their 56 engines that they use found that it was some type of malware. Oh, this little apple symbol right here, it checks to see if this apple root is in the signature chain, and it just tells you that it is. And then the color is giving you a score. We can go in and we can graph. You probably can't even see that. And it'll graph it like the time. Things we still need to work on a little bit, but so that's one. If we want to go in and just upload, we just have a big file. I think I labeled it big. Yep. So this one we don't want to run analysis because I know I think it has like 200-something thousand lines in it, and we'd be here all day waiting for it. So we'll give it the -n flag, which should just import it. And we go back to Strata. Should pop up here without having to refresh, but and we wait, and we wait, we wait. It says it's done. Okay, so it popped up here. So project name Goku. I'm a Dragon Ball Z fan. Had to throw something in there. So, and we'll see that it didn't run analysis, so there's 0 flags on everything. So we want to go in and run our own analysis. So I'll go into applications. What I'll do is I'll just select all those applications, and then I'll go down to this little button here. So this gathers all those IDs of what it's going to send. So these are all the hashes that it's going to send to whatever API or third party we want. So we'll just send the shadow. So you can see that it's updating. It'll give us these labels over here on the right that it ran through shadow. So green means that it was in shadow server's whitelist, and orange just means that it wasn't. Doesn't mean it's bad. It just wasn't in there. Then we'll also send to Xforce. And so you can see they're starting to populate as well. Oh, there we go. So, and then we can graph them. So this will give us so it's kind of hard because not everything in OSXCollector gives a date stamp with each item. So not all of them have dates to graph like on a line like this. So I want to add some other graphs here. Just haven't done it yet. But that's one of the nice things about using MongoDB. You don't have to have a structure on all your collections and your documents. They don't have to be the same. So like all of the accounts or all the applications in that collection don't have the same data. So like all these are the subsections within applications. So we have install history and applications. And so they differ in what kind of data they hold. So that's where MongoDB is really nice because I don't have to, I don't have to make them look the same when I import them everything. It just imports it and loves it. So, and then we can send, I'm just going to send one to virus total just because it takes so long because you have to do the 15-second delay on every request. So you can see these are all the requests that it's made from the UI to IBM or virus total. So we see virus totals popped up here. I'm sorry this is all kind of bunging up here on the sides, but that's what this screen is doing for me. So, and it didn't find anything. So we go back to that one. So these are some of the results. So virus total came back in -1, so it didn't find it. There's no record of it in virus total. And it gives us a date, and IBM didn't find it either. So this is the one bad thing using like signature-based analysis is you might get something that's totally new that's not going to be in any of those databases. But we're just we're not trying to prevent. We're just doing detection and forensics after the fact. So it works for us right now. So let's go into one that has. So this has in the applications. There's 2 that it flagged on analysis. We go here and we just want to show those. And so this one, IBM Xforce said it was adware, gave it a score of 2. Isn't necessarily the one I'm looking for. Might be this one. Yeah, this is the one. So we love these apps. Tune up my Mac because it's slow. Those are always malware. So this gives us a little bit better score. Well, not better. I mean, it's worse, but it's higher. I like to see stuff. And we can graph that and see where it falls in the graph. So one of them score at 20, and the other one's over here at 40 something. So the higher it is, the worse of the score. The more likely it's infected with something. So we went to, I think it's Objective-C, to get some malware, just to make sure that it was working like we wanted. And we downloaded 20, and it flagged 20. So we see lots of red. When we see lots of red, that means it's bad. So we go down here, and this will, the flag section here. Oh, I thought people were just coming in because it was awesome. Thanks. Um, so we can go down to this flag section, and that pulls all the flagged items from the whole collection. And we can graph and see when a user downloaded it. We can look at a time. It's kind of misleading because sometimes these times are just when that file was created. It's not necessarily the download time, which is a little frustrating, but that's something we'll have to fix. But we can see there's a lot of red, and I mean it picked up a lot. I guess a Trojan ranked at 50. I think the highest score in here is like 107. So, yep. Does anybody have any questions as we're going through this? Yeah. Yes.
Yeah, so the collector, yeah, it can run in the background. Our application that we wrote, it tells them to leave it open. It pops up a window say leave it open while it collects the data, and then it disappears once the data collections happen. But as far as performance goes, no, it's very simple. As far on the collection, this system is run on a separate server itself.
Yep. So we want to write part of that tool. We want to write that it just, instead of sending it to our ticketing system, we want to send it just directly to Strata. So that's something that we'll add into it later. But I think that's pretty much all from the app that we're going to show that's working right now. So let's go. There's a little bit more left in the slides. So roadmap, we want to create a dashboard of all the collection data. So like you can look at your company as a whole. You can see all these users have the same malware from the same source, type stuff like that. So more analytics and just, I'm a data junkie, so I like to visualize data and everywhere I can get it. So I still need, we need to work on the search for each tab. You go through, you want to be able to search through a specific time or a subsection or something like that. Flag everything like, so we want to put in, users can put in what they want flagged on analysis, on the automated analysis. So right now I have it set of anything that scores over a 3 to flag it. And so they can get pretty busy, like that one that has 3,000 flags in it. We want to narrow that down so we can spend less time. More data visualization. I already talked about the application that runs and automatically imports from Strata or into Strata. And then we also want to do something with the logs that OSXCollector gives us. And that's just going to require some more parsing of system logs. And so we're working on that.
And then one thing that's not on there is more for us. I don't know if it'd be useful for others. Is we want, obviously we stated that one of the things we want, why we built this is to have Corp IT staff be able to do initial analysis, and that way we want to be able to have that escalate and notify us through the system that something's been escalated to the security team.
And if you guys have anything that you would like to see in it or think that would be helpful, let us know, because we're always open to that. And we're going to open source this, so you could take it and do whatever you want with it. Yep. So hopefully by December 11th we can get it out there. Did you want to read that quote?
No, I'm good.
Okay.
I'm all right. They can read. But yeah, that's, you know, we really wanted to open source it again because we're a small shop and we're hoping that others will find value in the application and be able to help build it up, because obviously there's not much out there right now. OSXCollector, like I said, is an amazing tool. We're just trying to add to that by giving another option for analytics of the data. That's it, isn't it?
Yeah, I think that's less.
Yeah. The project, that's our information again. Easiest way to interact with us is Twitter. Those are our Twitter handles. And then this will be the GitHub. We've already created the GitHub repo for it, and we'll, like I said, be our goal is to get that released on December 11th of this year. Any questions for us? Go ahead. On what? All volumes? Non-booted volumes? That one I don't know. Oh, that's right. Yeah. Yeah, that is, yeah. And you can, and also with that, you can have the data dumped. You part of the, on the command line, if you run OSXCollector, you can dump it to a different volume as well, instead of the directory it was run. Anything else? Yeah, go ahead. Do you have another? Yeah.
Yep.
jQuery?
I
I think, isn't it a Go?
it's on GitHub somewhere.
I think it's written in Go, and I think you have to have Go installed, and then it will install it in your one of your paths. I'll double check, but that's what I remember. It's been such a long time since I installed it that, but that's what I remember. Did you have a question?
From OSXCollector, minutes. Yeah,
Yeah,
it
on
doesn't take long.
Yeah, on the OSXCollector, the data, it depends on the system. On our default message that we have that pops up on that application, it says 1 to 15 minutes, and I've never seen it run over 8. I mean, even on that one that collected, I don't have, 200,000 lines of data, it was really fast.
Yeah, the time is always going to be on the analysis. Like, if it's got to make 100 requests to virus total or whatever, it's just going to take just some time. But hopefully that can save you time when you go in. When you look at it, you don't have to spend all those hours of going through all that data. It can just already be done, and you can spend a couple minutes. So.
Yeah. I mean, for us, it sucks, but we feel like the dog on up, right? I mean, we just distracted every 5 minutes with different things, so it's nice just to have this analysis done for us, and so we can come back to it, because we just don't have that hour or 2 hours, whatever it takes to do the analysis, the advanced analysis via command line. Another question? Yeah, so it's interesting on that bid9. It's always fun when you are thinking through something of how you want to tackle something. You run with it, and then later you find the industry supporting what you're doing. With that bid9 report, it actually highlighted the tools that we're implementing in our environment. So we have OSXCollector is oh crap, something happened, what happened, right? It doesn't do any kind of prevention. Where we're looking more preventative is, and I'm embarrassed that I can't, it's stage fright, I guess, here. I can't remember the Objective-C guy's name, but if you go to Objective-C, this guy is a guru Mac expert, and he actually has some really good security tools on his site. We're working on implementing those. That will help provide. These will be more preventative type solutions for us. The knock knock, the task, knock knock and block are two of the ones we're focusing on. And then we've also implemented. We're in the process of implementing Facebook's OS query, another awesome tool. And something that you want to check out. So yeah, we're looking at how we can integrate all these tools together. But it's exciting to see. I think it also testifies to the fact that Mac OS is starting to see a lot of malware issues because you're having I mean, you have two big companies, right? Facebook and Malware that have developed open source tools around the platform. Um, so I think to me, it speaks to the urgency of starting to protect our Mac platform much better than we currently are.
Mac doesn't get malware.
Yeah, yeah. If you want to believe that, then yeah. Um, anyway, any other questions? Yeah. Um, yeah, we've identified like one of them. Right now, the only thing that identified, we've only identified in our environment adware, which is it's been nice though as far as at least now it's comforting to know to at least identify it because in the past we had no idea. We just saw all the event logs on the firewall and just had to wipe, but we had no idea how it got there. Here we actually can click or we can figure out where the person went and the fact that they actually did click on something and they took an action to download the malware. So, but other than that, I mean, you know, we've talked about how to. That's another feature that we want to look at is how when we see all these alerts triggered, how can we get that data and actually upload it to someone like Blue Coat for further analysis, right? That's another feature that we'd like to add to it.
Any more?
Okay, that's it. Feel free to contact us, and thanks for your time.